What happens when you break one of mathematics' most fundamental rules? Why does every calculator in the world refuse to divide by zero? And what cosmic mathematical disasters would unfold if we tried? Welcome to a journey into one of mathematics' most important prohibitions. I'm your host, and today we're exploring why division by zero isn't just impossible, it's the guardian of mathematical logic itself. Before we understand why we can't divide by zero, let's make sure we really understand what division means. When we say 12 divided by 3 equals 4, we're really asking, how many groups of 3 can we make from 12? The answer is 4 groups. But here's the key insight that most people miss. Division is really the inverse of multiplication. When we write 12 divided by 3 equals 4, we're actually saying that 3 times 4 equals 12. This relationship is absolutely crucial to understanding why zero creates problems. In general terms, a divided by b equals c means that b times c equals a. 15 divided by 5 equals 3, because 5 times 3 equals 15. 20 divided by 4 equals 5, because 4 times 5 equals 20. 7 divided by 1 equals 7, because 1 times 7 equals 7. This all works perfectly until we introduce zero. So what happens when we try to divide by zero? Let's use our definition. If 8 divided by 0 equals some number, let's call it x, then that means 0 times x should equal 8. But here's the problem. 0 times anything is always 0. 0 times 1 equals 0. 0 times 100 equals 0. 0 times 1 million equals 0. There's no number x that you can multiply by 0 to get 8, or any non-zero number for that matter. So 8 divided by 0 has no answer. It's undefined. But wait, what about 0 divided by 0? If 0 divided by 0 equals x, then 0 times x should equal 0. Now we have the opposite problem. 0 times 1 equals 0. That works. 0 times 2 equals 0. That works too. 0 times 47 equals 0. That works. 0 times negative 5 equals 0. That also works. Every number works. 0 divided by 0 could be 1 or 2 or 47 or negative 5. When a mathematical operation could have any answer, we call it indeterminate. Both cases break the fundamental requirement that mathematical operations should have unique, well-defined answers. But the problems don't stop there. What if we ignored these problems and just said that division by 0 equals some number? Let's see what mathematical chaos would ensue. Let's assume that 1 divided by 0 equals some finite number. I'll call it k. If this is true, then by our definition of division, 0 times k equals 1. But we also know that 2 divided by 0 should equal 2k, because if 1 divided by 0 is k, then 2 divided by 0 is twice that. So 0 times 2k equals 2. Now watch what happens when we use basic algebra. We know that 0 times 2k equals 2, but let's break this down step by step. 0 times 2k equals 0 times the quantity 2k, which equals 0 times 2 times k, which equals 0 times k, which we already established equals 1. So we've just proved that 2 equals 1, and we could use the same logic to prove that any number equals any other number. 3 equals 7, negative 5 equals 100, pi equals 42. This is what mathematicians call a contradiction. We've derived an obviously false statement from our assumptions. Therefore, 1 divided by 0 cannot equal any finite number. In fact, allowing division by 0 would make all of mathematics collapse into nonsense. Every theorem, every proof, every calculation would become meaningless. Now you might be thinking, but what about infinity? As numbers get smaller and smaller, doesn't 1 divided by those numbers get infinitely large? You're absolutely right. As the denominator approaches 0, the result does grow without bound. This is the concept of a limit. Looking at the graph of y equals 1 over x, we can see what happens as x approaches 0. We say the limit of 1 over x as x approaches 0 from the positive side is positive infinity. But here's the crucial detail. If we approach 0 from the negative side, we get negative infinity. Since the left and right limits don't match, the overall limit doesn't exist. And even if it did, infinity isn't a number in the traditional sense. It's a concept representing unbounded growth. This is why your calculator shows error rather than infinity, because mathematically we haven't actually calculated a value. we've encountered a situation where no finite answer exists. Here's the key distinction. Limits describe behavior near zero. Division asks for an exact value at zero. These are fundamentally different questions. A limit tells us about a journey, what happens as we get closer and closer to zero. Division by zero asks about the destination, what happens when we actually arrive at zero, and that destination simply doesn't exist. Now, mathematicians are creative people, and some have asked, what if we create new number systems that do allow division by zero? One approach is the extended real number system, which adds positive and negative infinity as points at infinity. In this system, we can say that 1 divided by 0 equals positive infinity. So 1 divided by 0 equals positive infinity. Negative 1 divided by 0 equals negative infinity. Infinity plus 1 equals infinity. Infinity times 2 equals infinity. But even here, 0 divided by 0 remains undefined because we still can't decide whether it should be positive infinity, negative infinity, or something else entirely. There's even something called wheel theory, which creates a new number called nullity to represent the result of 0 divided by 0. But these systems sacrifice other useful properties of arithmetic. The key insight is that mathematics is about making consistent, useful systems. Standard arithmetic chooses to keep division by 0 undefined because it preserves more important properties, like the fact that if A equals B, then a plus C equals B plus C. It's a trade-off, and standard arithmetic makes the choice that preserves the most useful mathematical structure. So why can't you divide by 0? We've seen 4 crucial reasons. First, it has no unique answer. Division by 0 either has no solutions or infinitely many solutions, neither of which gives us the single, definite result that division should provide. Second, allowing it creates logical contradictions. If we permit division by 0, we can prove that any number equals any other number, destroying the logical foundation of mathematics. Third, limits aren't the same as division. While we can study what happens as we approach 0, that's different from actually dividing by 0. And fourth, alternative systems that allow some division by 0 must sacrifice other valuable mathematical properties. So the next time your calculator refuses to divide by 0, remember it's not being stubborn or limited. It's protecting the entire logical structure of mathematics from collapse. Division by 0 isn't forbidden because mathematicians are rule-obsessed. It's undefined because defining it would break something far more important, the consistency and reliability that makes mathematics work. Thanks for joining me on this mathematical journey. In mathematics, some rules exist not to limit us, but to set us free.